do a quick recap of what we did last class, and then we will continue with some more material. Anything that you need to know from this chapter will be in this PowerPoint. There's just one slide. I'm not putting additional slides for different classes. I'm combining it all into one slide. So please just review this one PowerPoint and solve the homework problems, and you should be okay for the next test on this one. All right, so what we did last class was we continued with what we started in the first time we met when I taught you about the one-leg robot in the lab. All right, so if we have a one-link robot, we can position the link at different orientations, and we can plot for every orientation. There's a projection of the horizontal axis and a projection on the vertical axis. That's given by x, which is L cosine theta, and the vertical is y, which is L sine theta. So you can plot. So note that there is no time dependence here. Nothing changes with time. You keep it at a certain position, and you find out what x and y are. So when you plot this as a function of theta on the x-axis in radians, and both x and y, we plot both x and y on the same graph, and we get two curves, and we notice that they are periodic. So the behavior repeats after every 2 pi radians, so we say that this is periodic with a period of 2 pi. Then we saw the next case when instead of putting it at a certain position, we allow it to go around and around. And at what angular velocity do we allow it to go around and around? That is given by omega, which is the angular velocity in radians per second. And theta is the position, omega is angular velocity. And now, before, theta was not a function of time, it was a fixed number. And now, since it's changing with time, instead of theta, we insert omega t. And instead of plotting as a function of theta, now we plot it as a function of time. Okay, so we vary time from 0 to t seconds, which is a period, and we plot one full cycle. So instead of plotting x and y as a function of theta, we now plot x and y as a function of time. All right, so we also define a new term called frequency. There's a difference between omega and f. Okay? Omega is the angular velocity. F is a linear frequency. Notice the change different units. Omega is in radians per second. So the amount of angular displacement per time is your omega. F is the number of cycles per second. So since one cycle is 2 pi radians, right, in this case everything's periodic with the period 2 pi, so F is related to, F is the inverse of t, which is the period. Right? So F is nothing but 1 over t. All right, now let's talk about what's called as the phase shift. So in the experiment that we just did, if you go back and look at the previous curve here, all right, if you look at the sine theta curve, at time t equal to 0, where is that curve? What is the position at time t equals 0? That's the red curve I'm talking about.
0.
It's at 0, right? So what you're doing is, when you start the plot, you're keeping the arm at theta equals 0, and then you allow it to go round and round. Instead of doing that, let's say we keep it at theta equals 30 degrees, and then allow it to go round and round. And that's exactly what we will be doing when we talk about phase shift. So instead of starting at theta equal to 0, at t equal to 0, I'm going to rotate the length of the robot pi by 8 radians, right? And then I'm going to turn the motor on and let it go round and round. So what will the plot look like as a function of time? So let's look at the equation first. So theta, I said, was omega t. So theta is the position, omega is the angular velocity, right? So angular velocity is radians per second. You multiply it by time, which is in seconds, you get radians. So theta is radians. on the left-hand side. On the right-hand side, you have omega times t. Omega is the radians per second, time is in seconds, the two times cancel it, and you get theta in radians. So when you start at theta equals 0, you don't need this extra term phi here, because you simply substituted theta equals omega t. But now if you don't start at theta equals 0, you start at some other value of theta, then you add this extra term here, phi. Now phi is, you can think of phi as the amount by which you offset your length of the robot and then start. Okay? So instead of being x equals L cosine theta, we will now plot x equals L cosine theta plus phi. Right? So what does this mean in terms of the plot as a function of time? Right? So you're offsetting it by a certain angle phi. And how much time should we slide the curve to the left or right? So the dotted line that you see there is your original plot, which is when phi is 0. So it is just sine L sine omega t. Phi was 0. Now that I've introduced a phase shift, my curve has to move left or right because I'm shifting the initial position. You with me so far? So we have to find out if you rotate by a certain angle, how much should you shift along the time axis in order to accommodate that, right? So in this particular example, we say that the angular velocity omega is 2 pi radians per second, and the phase shift is pi divided by 8 radians. So which is the same example that I had here, right? So if I phase shift by pi by 8, how much should I slide the position versus time curve left or right in order to represent that, right? So if omega is 2 pi radians per second, radians divided by time, all right, and the phase shift is pi by 8 radians, so time would be pi by 8 divided by 2 pi, or 1/16 of a second. So changing it by, or shifting the phase by an angle of pi by 8 with the angular velocity omega being equal to 2 pi introduces a phase shift of 1/16 of a second. So you can take that curve and simply slide it to the left or right, depending on whether your phase shift is positive or negative, 1/16 of a second to the right or to the left. Okay? Let's talk a little bit about harmonic motion. That's the next section. It's a fancy word, but what it essentially means is that your force is proportional to the displacement. You have a cart and a spring attached to it. The more you pull the cart, the greater is the force with which the spring is going to pull the cart. Right? So that's given by the expression y of t is a sine omega t plus phi. Right? This is very similar to the expression you just saw before. Right? So look at this, L sine omega t plus phi, and look at this, a sine omega t plus phi. So a is the amplitude. So what we're doing is we're taking this cart attached to the spring, we're going to pull it a certain distance and we're going to let go. And that cart is going to oscillate. Right? If there is damping or friction, what will happen is the cart's amplitude will change with time and it will eventually come to a rest. But in an ideal world, we're going to assume that there's, or in a mathematical world, we can put the friction to be 0, and if you pull it and let go, it will simply continue to oscillate for eternity. So we're going to assume that that's what's happening, and we are going to plot what this behavior looks like. So A is the amplitude. So amplitude is the distance by which you pull the peak displacement from the mean. Okay? And omega t is your angular velocity. Omega is your angular velocity, and phi is your phase shift. All right, so let's do an example here. So in the exam, you'll get a problem like this. So a simple harmonic motion is given by the equation y of t is 2 sine 6 pi t plus pi by 2 meters. Now what does this mean? So this has a bunch of information. So think a sine omega t plus phi, and let's find out what a, omega, and phi are. Right? So a is 2 meters. Omega t is 6 pi t, so that makes omega equals 6 pi. Okay, radians per second. So what does that mean to you? If I tell you omega is 6 pi radians per second, what does that convey to you?
The number of cycles, the
Yep,
harmonic
so in
motion.
1 second, if it does this, it's 2 pi, 4 pi, 6 pi. Right? So 6 pi radians per second means the cycle repeats itself 3 times. And that's where you get the linear frequency, 3 hertz or 3 cycles per second. Okay? All right, so period. So if you do 3 cycles in 1 second, how long would it take to complete 1 cycle?
30 seconds.
Third of a second. Right? So if you think in terms of formula, it would be confusing. Yes.
For the third line, linear frequency was 2 pi divided by omega.
Mm-hmm.
Can they give you a third? Because 2 pi divided by 6 pi.
Phase shift also.
Linear frequency, yeah, it should be omega divided by 2 pi. I'll correct that. Thank you. That's fine. Thank you. All right. So phase shift. So if the last one is the phase shift, 6 pi t plus pi by 2. So that is the phi. So phase shift is 90 degrees. And you can also translate the phase shift into time like we did before. So if you're phase shifting by pi by 2 and if your omega is 6 pi, your time shift is 1/12 of a second. Okay? And in the exam, you'll also be asked, what is the displacement at time equals 2 seconds? So remember that expression is a function of t. So in every function, there is a dependent and an independent variable. The dependent variable is y and the independent variable is t. Right? So for a certain value of an independent variable, you would be asked to find the value of the dependent variable. So in this example, the question is for the above function, find y of 2. So which means you set your independent variable and your time variable to be equal to 2, and you find out what your dependent variable or your space variable is. Okay? And you can also do this using MATLAB. And using a slightly different style to do the same thing. Right? It's you can do it the way I taught last class, or you can do it this way. So the command is slightly different. So I use what's called as an inline function. So I could define a function separately and create a linear space of the independent variable. And for each entry in the independent variable array, I can find out what the dependent variable is. Or I could define an inline function. So instead of separately defining a function, I just say plot that function from 0 to 3 seconds. All right? This, you don't have to take a picture. This is, I've posted the code on Blackboard. Right? So you can download that file, harmonic.m. Everything is there. Okay? So I want you to download these and practice them on your MATLAB. And if you have MATLAB issues, feel free to come and bother me. So one of our goals is to make sure you're very comfortable with MATLAB, because it's a very, very useful tool to, especially in calc and linear algebra, you're dealing a lot with equations, and sometimes you have a hard time putting a picture to those equations. Right? So when you just simply enter that in MATLAB, you'll get a very nice pictorial representation of all the math, and it makes understanding so much easier. So MATLAB is a very, very powerful tool to help you get through math. All right, so let's look at this. Yes.
What's the difference between f-plot and line space?
F-plot is you plot a certain function. Lin space is simply a linear space. It creates an array. I could just say create an array called X with 5 entries going all the way from 0 to 4. So that will simply create a variable or a vector called X, and that X will have 5 slots. And it'll have values 0, 1, 2, 3, 4. Okay, that's what lin space does. Okay, you can take that lin space and feed it to a function. So instead of doing it using an inline function, which is what this is. Okay? I could create a lin space. So lin space is sort of embedded there when I see 0, 3. That's not an explicit statement for lin space, but that's what MATLAB is doing. So it's creating a lin space between 0 and 3, and for that values of time within a variable, it's plotting that particular function. Okay? So you can take all that command that I did last class and kind of roll it into one command in this there. All right, so let's see if the picture makes sense with what we thought it should look like. So in 1 second, we had 3 cycles. So let's see if we get that. We start at 2, and in 1 second, you go back to 2, and you've done this 3 times. So you've had 3 peaks in 1 second. Okay, so, or you have 3 cycles. So omega is 6 pi radians per second. So the picture matches the equation, and we're happy. So we move on to the next example. All right, so here we're going to talk about how to add 2 sinusoidal functions. Okay? So we have the first function, 6 sine 2t, and another function, 8 cosine 2t. Now we're going to add these 2 sinusoids. Right? So I want a volunteer to tell me what 6 sine 2t means to you. No, forget the physical interpretation of it, but what does 6 sine 2t mean in terms of sinusoids? So what does 6 mean?
Amplitude.
6 is the amplitude, and what does 2 represent? In per second, yeah. Right, so think of it as the equivalent of linear velocity, so the feet per minute, or meters per second. This is radians per second. All right, so amplitude is 6. The angular velocity is 2. So angular velocity is 2 radians per second. So what does that mean? Two radians per second. So pi radians is 1/2 revolution. So there's no pi there. Be careful, right? It's just 2 radians per second. Okay. So our goal is to add these 2 now. And this is how we do it, right? So the addition of these 2, we call that V of t. Right? And we're going to add these 2. And we say that our answer is going to be of the form, all sinusoids have to be in the form a sine omega t plus phi. So we say the answer is of the form mu sine omega t plus phi. So when you add 2 sinusoids of the same frequency, your answer is also going to have the same frequency. Okay? So both sinusoids there, 6 sine 2t and 8 cosine 2t, have omega equals 2 radians per second. And we're going to add these 2, and we will say that the answer is also going to be of the same form. Amplitude, sine, omega t plus phase shift. Right? Now our goal is to find out what this mu is and what phi is. So when you add 2 sinusoids, you're going to get a sinusoid. You have to find the combined amplitude. You have to find the phase shift if there is one. You don't have to worry about the frequency because we're doing an example where both the waves have the same frequency. Okay, so there is a trigonometric identity. Sine of A plus B is sine A cosine B plus cosine A sine B. Are you familiar with that identity? Yeah? If not, you should memorize that particular identity. It will serve you well throughout your engineering degree. So what we do is we have the right-hand side. All right, so it's what we will do is we will take the 6 sine 2t plus 8 cosine 2t, And we will expand the right-hand side. So I keep the left-hand side unchanged, and the right-hand side I have mu sine 2t plus b. So that's of the form sine A plus b. Right, so I can write that as sine A cosine b plus cosine A sine b. Right, so sine A is sine 2t, cosine b is cosine phi, and then vice versa, cosine 2t plus sine phi. Okay? And then I'll expand the parentheses. Okay? You might want to write along with me, it will make more sense. Looking at it might seem a little confusing. Writing it will really simplify this process for you. There's a lot of terms here, so if you stare at it, you're likely to get lost. So solve this along with me. All right, then in the next step, we're going to expand those parentheses. All right, so the first term is, so I expanded with an intention in mind. I just don't distribute the mu across the two terms, but I look at what I have on the left-hand side and I look at what I have on the right-hand side. Right? So the first term, mu times sine 2t times cosine phi, I can write it as a coefficient times sine 2t. So compare this term with this term here. You have 6 sine 2t. You have something inside the parentheses times sine 2t. So that something inside the parentheses has to be equal to 6. We will do the same thing for this. So if I distributed the mu over this cosine 2t sine phi term, I would have mu cosine 2t sine phi, but I rearrange the terms slightly, and I make it appear something very similar to this. So I have 8 cosine 2t here. So I have something cosine 2t. So this something has to be equal to this. Okay? So that's what I have here. So in the first expression, mu cosine phi should be equal to 6. And the second one, mu sine phi should be equal to 8. Okay, so I have two equations, and I have two unknown quantities, mu and phi. So I can find mu and phi by, I can square these two equations and add them. And if I were to square and add them, I would get mu squared, cosine squared is phi plus sine squared phi. Here's another identity. Cosine squared theta plus sine squared theta is 1. Right? So this simply becomes mu squared because this whole thing goes to 1. And on the right-hand side, I have 8 squared plus 6 squared. 64 plus 36 is 100. Mu squared is 100. Mu is square root of 100, that is 10. So you have the magnitude of the combined wave. Now we have to find phi, or the phase shift of the combined wave. All right, so you have two expressions. One is a sine and one is a cosine. What will happen if you divide one by the other? The mu's will cancel out. And sine divided by cosine would be tangent. And on the right-hand side, you have a number. So that's what we do. We divide mu sine phi by mu cosine phi. Right? Mu's will cancel out. All right? And we have tangent to phi is 8 divided by 6. And then we can find phi is arctan 8 divided by 6, which is 53 degrees. So we have taken these two waves and we have combined them together. And you will also learn this in physics. You take waves and allow them to combine with each other constructively and destructively. And, have you done this experiment in high school? Where you have one source of light and you take cardboard and poke 2 holes in it, and you allow the light to go through those 2 holes. And if you put a screen there, what do you think you're going to see? Are you going to see 2 dots where the 2 light pokes out through the cardboard? What are you going to see? So I have one light source, I have a cardboard here with two holes poked in, and I have a screen here. What will you see on the screen? Two dots where the two holes are? No? One dot? What are you gonna see? Now let's not think in terms of light. Let's do the same experiment with water, right? So I drop a stone, and waves go out in all directions. And I have a cardboard, okay, and I poke two holes in the cardboard. And what's going to come out of those two holes? Two waves, right? And what's going to happen when two waves can interfere constructively or destructively? If they interfere destructively, one has a positive amplitude, one has a negative amplitude, and they annul or cancel each other. If they interfere constructively, if they have the same amplitude, it will be twice the amplitude. Right? So the same thing that happens with water happens with light. So light comes out of these two holes, they're in the form of waves. Okay? So they go into constructively and destructively interfere, and you'll see a pattern of dark light, dark light, dark light bands. Right? So we're doing something like that. We are taking two sinusoids, and we're allowing them to interfere, and we're finding what the combined answer looks like. Right? So we took two sinusoids, 6 sine 2t and 8 cosine 2t, and we allowed them to interfere, and the answer looks like this. So in this course, you will not be asked to allow waves to interfere that don't have the same frequency, but you could definitely do that as well. Right? So in the exam, as far as this is not going to be on your Wednesday's exam, but do the homework problems. So the questions you can expect are, I will give you a function, and I'll ask you to tell me what the amplitude is, what the frequency is, what the phase shift is, and I will ask you to plot it. So in the test, you do not have the luxury of MATLAB. All right, so also try doing this by hand. Pick certain values of theta, let's say 0, pi by 4, pi by 2, 3 pi by 2, 2 pi, etc., and learn to plot it by hand as well, because you're not going to be allowed to use MATLAB in your exam. Right, so do both by hand as well as using MATLAB. Yes.
Can you explain how you got to 10 again?
I think I can explain. Yeah. So, are you okay with these two expressions? Right. So I can square these two and add them. So if I square this, I'll get mu squared cosine squared phi is 36. And I'll get mu squared sine squared phi is 64. If I add those two, I can take the mu square outside, and I would have cosine squared phi plus sine squared phi. Regardless of what phi is, this number is always, the sum of these two is always equal to 1. Right? So we can come up with some values, right? What is cosine 0? Yeah.
Cosine 0 is 1.
What is sine 0?
0.
So what happens when you add these two?
1.
1. Let's try another angle, right? Let's try pi by 4. What is cosine pi by 4? 1 over
Root 2.
root 2. What is sine pi by 4?
1 over root 2.
Let's square them.
Root 2 over 2.
1 over root 2 whole square is 1 half. So 1 half plus 1 half is 1. Okay? So for any angle phi, sine square phi plus cosine square phi is always 1. So we have mu squared, we force this whole thing to go to 1. And on the right hand side I have 8 squared plus 6 squared, which is 100. So if mu squared is 100, it will equals 10.
Why is it mu cosine theta equals 6? Shouldn't it be the opposite? Shouldn't it be switched around, 8 and 6?
Is there a typo there? Mu cosine should be 8 and mu sine should be 6.
Cosine should be 8.
Yeah, I'll fix that close. You're right. So this term here.
Repeat that, be the opposite.
No, I think we have it.
Why is it?
See, sine 2t has a coefficient of mu cosine. And sine 2t is 6. So mu cosine phi is 6. Cosine 2t has coefficient of mu sine phi. It is correct. It's on its own. Okay. Any other questions? I'm gonna go see if I could drag them down and talk to you a little bit about the test and answer.
Yes, please. Thank you.
Sorry, I did not make this test, so I don't know anything about it.